Recording in progress. Recording in progress.
Okay, guys. Why am I getting an echo? Oh, this is horrible. Hey guys, it's me. It's 2022. I haven't done this in a couple of years, so I'm going to try to make you a video since I'm out with the grandbaby today. We're going to find differentiability at a point. Well, there's two things that we have to do to decide if something is differentiable. We have to know that it's continuous. Has to be continuous. And the derivative from the left and the right have to be equal. So f prime of c from the left has to equal f prime of c from the right. So at 4, do we know that this is continuous? Well, yes, it's continuous because 4 is not an undefined value. Now, we don't know how to find derivatives of absolute value, but we do know that if we were to put this in, or at -4, we know that there's going to be a sharp turn, so we know it's not differentiable at x equals -4 because the slopes aren't going to be equal. We haven't learned how to do derivatives of absolute value, but we can just think about that one. Okay, this one, number 2, how are we going to do this? I want to know if it's differentiable at 1. First, I need to see if it's continuous. Is it continuous? Okay, well, I'm going to put -1 into both of those functions and decide if I get the same value. So it's -2 times 1 squared plus 4 equal to 1 squared plus 1. This is going to be -2 plus 4. I'm asking, does that equal 1 plus 1? 2 equals 2. So yes, it's continuous. Now I want to know if it's differentiable. Might as well check continuity first. And so I'm going to find the derivative. So I'm going to do f prime of x from the left is going to equal -4x because I swung and subtracted this right here. And then I'll do f prime of x from the right is going to equal 2x. And because I swung and subtracted this. And then I'm going to try it at 1. So does f prime of 1 from the left equal f prime of 1 from the right? I don't know. Well, that would be -4 times 1. And does that equal 2 times 1? And the answer is no. That means that the slopes don't match up. That must have a sharp turn. It's continuous, but the slopes don't match up. They're approaching different numbers. So no, this is not differentiable. Okay, so 1, is this continuous? Well, yes, I can put I can do a 5th root of 0. So the answer is yes. 2, I'm going to decide if it's differentiable. Okay, so I'm going to find the derivative. So f prime of x, I don't have a left and right, so I just need to see what happens. F prime of x is going to equal, and that would be to the 1/5 power. So it would be 1/5 x plus 2 to the -4/5, which is going to be 1/5 x plus 2 to the 4/5. And I know that if I do f prime of x at -2, that's going to be 1/5 times 0 to the 4/5. That's undefined, so it's not differentiable. Remember, the derivative has to exist and the left side has to equal the right side. In order for the derivative to exist, the left has to equal the right, but it has to exist, and it doesn't here. So not differentiable because this is undefined, because you'll get 0 in the denominator of the derivative. You have to check the derivative. Okay, let's try this one. Well, first off, it's ask if it's continuous. I'm going to put 1 in. So I'm going to go 2 times 1 squared plus 1. Does that equal 2 plus 2 times 1? And that's going to be 2 plus 1. Does that equal 4? No, I stopped there. I don't even need to ask. It's not continuous. So I don't even need to figure out anymore. Not continuous. So not differentiable. Okay. All right, let's try another one. 1 is continuous. Okay, so I'm going to put 2 times 1 plus 3. I'm looking at x equals 1. Oh, that should have been -1. Oops. This question up above should have been -1. Well, that wouldn't have changed that, but it would have changed this to 0, but the answer is still no, because you'd square that, and that would be negative. I didn't see the -1. Okay, so the answer is still no. Okay, so here we're doing it at +1, and we're asking, does that equal 1 squared plus 4? And so you get 5 equals 5, so it is continuous. So now I check differentiable, which means the slopes from the left and the right have to equal each other, okay? So I'm going to find f prime of x from the left is just 2, and f prime of x from the right is 2x. So then I'm going to check at 1. So f prime of 1 from the left is going to equal 2. Does that equal f prime of 1 from the right? Does that equal 2 times 1? 2 equals 2? Yes. So yes, continuous. Yes, differentiable. Okay. And then here's another one. So I know that this is continuous because I can do -8. I can do the cube root of that squared. So yes, it's continuous. Okay, now differentiable. I'm asking, okay? So f prime of x is going to be 2/3 x to the -1/3, which equals 2/3 cube root of x. Okay, well, as long as it's defined, it's going to be approaching the same number. So now I'm going to do f prime of -8. And I'm going to put that 2/3 cube root of 8, which is 2/3 times 2, or 1/3. It's defined. It's going to be approaching the same number because I know it's continuous. So as long as it's continuous and the derivative is defined at that point, then yes. So yes, differentiable at that point. Okay, now how do you find A and B? Well, you have to make sure that it's continuous, and then you have to make sure that there's no sharp terms. So you have to set the functions equal at that point, and then set the derivatives equal at that point. Okay, so you set the functions equal, f of must be equal from the left and the right, and then you set the derivatives equal. That's basically what you do. This means you set the function equal, and this means you set the derivatives equal. Okay, so to find the value of A and B, I'm going to say A times 1 plus B equals B times 1 squared minus 1. So A plus B equals B minus 1, or A equals -1. Now I'm going to set the derivatives equal. And so I'm running out of room. I'm going to have to make this a lot smaller and zoom in. Okay, so we're going to do now the derivatives. Okay, so the derivative, that's making sure it's continuous. I know when A is -1, I don't know B yet, but I know when A is -1, it's continuous. And then I'm going to find B. Since I have 2 variables, I need 2 equations. Well, I've got to find the derivative. So the derivative f prime of x from the left is just going to be A, and f prime of x from the right is going to be 2bx. And I want to set those equal. So A is going to equal 2b times 1. So A equals 2b. Well, -1 equals 2b, so b equals -1/2. So if a is -1 and b is -1/2, that will be continuous and differentiable, okay? I just did a system of equations. So step 1 is I set the functions equal. That's what I did, functions equal. And then step 2, I set the derivatives equal. And I solved for the a and the b, okay? All right, here's one. And so we're going to step 1, we're going to set the functions equal. So a times pi squared plus sine pi has to equal 2 times pi minus b. So there's nothing I can do with a times pi squared. Sine of pi is 0. And that's just going to be 2 pi minus b. So there's really not a lot I can do with that. It's a system of equations. I'm going to have to figure out what goes on with the next one. So now is it differentiable? So I'm going to find the derivative. So the derivative from the left is going to equal 2 times a times x, swing and subtract. And then the derivative of sine is cosine. And then the derivative from the right is just going to be 2. So I'm going to set them equal when x equals pi. So I'll say 2a pi plus cosine pi equals 2. So there's nothing I can do with 2a pi, but the cosine of pi, so that's over on the other side is -1. So this is going to be -1 equals 2. So 2a pi equals 3. So a is 3 over 2 pi when you divide both sides by 2 pi. So now I have a, so I can go back over here and replace a with what it's equal to. And so that'll be 3 over 2 pi times pi squared is going to equal 2 pi minus b. I'm trying to solve for b now. One of the pi's are going to cancel. You leave one on top. So it'll be 3 over 2 pi equals 2 pi minus b. I'll move the b and the 3/2 over. So b will equal, and 2 minus 3/2 is 1/2. So it'll be 1/2 pi. So there are my different answers for a and b. Okay. So what do we do on all of these? You make sure they're continuous by setting the right side equal to the right side. And then you make sure they're differentiable by setting the derivative from the left equal to the derivative from the right. That's it. Okay. Have a great day. Bye.